Hello. Hi, hello. I'm Tomas Barros from NIC Chile, from the research lab at NIC Chile, which is a pretty new research lab. NIC Chile is the top-level domain of .cl, and I'm here to present you one research we have done using a simulator to analyze our network. So this is our network looks like. We have several resolvers around the world. Anyway, most of the resolvers outside Chile are contract. We have mainly with Autonomica, I think. They give us the service of DNS resolver. So we don't control dot servers. But in Chile, we have 4 servers. And this is in 2007. You will see later why I'm talking about 2007. So we have 3 servers in a cloud that are called Santiago, Tucapel, and Valparaíso, which are different cities in Chile, and they are located in different cities. And we have one unicast server that is called LONAP, and each one is connected to a different internet service provider in Chile. And we may have questions. I mean, we always have questions like how strength is our net. I mean, what will happen if a server crash or 2 servers crash? And the third question also is interesting, that which combination is best? Should we put more unicast servers resolving DNS queries, or should we add more nodes to the actual cloud that we have there? And the problem is that we cannot test that in the production infrastructure, because I mean, we just cannot put down several servers at the same time without affecting the service. So we are proposing in the research labs at NIC, we are proposing to use a simulator to do that kind of analysis. And this is how we did our simulation. We make a big abstraction of the net, where we put 4 autonomous systems representing 4 different internet service providers. Each one of the nodes is connected to one of these autonomous systems. For the simulation, we use the Georgia Tech network simulator, which is a real implementation of Zebra over NS2. That is probably the most used network simulator in the academia, and it's mainly used for testing new protocols. And we have programmed the DNS server and also DNS resolver or client that use a round-robin policy and choose the best round-trip time as the default DNS server. I'm going to skip that. This is how it's done. Is the simulation work with C++ files. And here I have the results for one experiment. This is for validating the model. I mean, in 2007, and that's why I was talking about the 2007 network, we did a real experiment in the real network where we have shut down the node Santiago in the Anycast cloud. And we have this data, so we have making the simulation in the same settings to validate that our simulation will be close to reality. That's the result. For the simulation, we have used a query rate that is the average. I don't know if I have a pointer. Yeah, that is the average of the real case. And as you can see, it looks very, very similar, at least the distribution of the queries on the other servers. But since we were interested in how the redistribution of the queries was happening, we used the percentage. And there is much more closer. I mean, after this first try, we realized that maybe it can be useful. I mean, we wasn't sure at the beginning, but after we ran the experiment, we see that the simulated case was really close to the real case, so a simulation of the net can be useful for further analysis. And in fact, we did. Sorry. We were playing around with the simulator. The last year at NIC Chile, we added a new node to the cloud that is located in LA in the United States. And this, well, we took the bandwidth and the round trip data we put in the simulator, we add the node, and this is our result. So at the beginning, the client preferred the cloud, and specifically the LA node. But after a while, because of the round trip and because of the best round trip policy that have the client, they choose NS that was closer, was in Santiago. The funny thing, this is the simulation case, but the funny thing that does this happen in reality, when they just plug the LA node to the cloud, all the charge went first to LA and then to NS, and was really close. I don't have this data yet, so I cannot show you the graph. So again, the model was validated again. And we play a little bit more. So instead of adding the LA node to the existing cloud, we made a new cloud, putting together NS and LA, and there we have much better results, at least in the distribution of the queries. And as we expected, the LA node didn't receive any queries, which is normal because it's supposed to serve only the queries coming from the States and not from Chile. Okay, and we have only the traffic coming from Chile. So the conclusion are that the results are promising. In the experiment that we compare with the real case in 2007, we have only 7% of difference. So the tool can be really useful to analyze further configurations. This methodology, we believe, can be applied to other applications that use the net, especially distributed applications. We want to use it too for analyze new technologies. I mentioned here, like using DNS, but instead of UDP or TCP running over HTTP, or what we have if we switch the full DNS query to TCP. And in future work, we need to refine this model and make more testing and analyzing. We want to make a friendly tool, so it can be used, a configuration change in the simulator doesn't mean that you have to write a full C++ file and recompile and rerun the simulation. So we want to provide some kind of easy language to make change. Well, refine the simulation, of course, to get closer to reality. And the last one is a PhD subject, in fact, beginning. We want to make a simulator that can be dynamically updated. And then we can plug this dynamic updated simulator to the real data in the servers. So we want to have always the simulator up to date, and we can, every time we want, we can make some testing over the simulator to have at least a taste of what will happen if we do the same in the real network. And that's all. I don't know, any question, critics, whatever.